Howdy, howdy, calculates. So we've already started to talk about concavity, and here's a calculus definition. So if I have a differentiable function and I am increasing, the slope is increasing, I should say. So here I notice, oh, I'm going from a positive slope to a negative slope. So if I'm going from positive to negative, this would be decreasing, while this one is going from a negative slope, so all the tangents along here have negative slopes, to a positive, because all the tangents along here have a positive slope. So if I'm going from a negative to a positive, of course if I'm moving from negatives to positives on a number line, I'm increasing. And when it's decreasing, it's concave down. So this is concave down. Oops. And when it's increasing, it's concave up. So this one is concave up. And then I look at this crazy one on the right, and I ask myself, what's happening? Well, as I follow along this one, my slopes are decreasing, and just think it might be going from like a +2 to a +1 to a 1/2. So clearly the lines are getting less steep. So this is decreasing on this side. But on this other side, I'm increasing. So this left side is concave down, but the right side, this side here, is concave up. And remember, I described it as you have laws of physics say that whatever object this is really wanted to keep this parabolic motion, and whatever object this was really wanted to keep this parabolic motion. And what happens is I sever them right here, and I erase all of this piece and I erase all of that piece, and then I get out my handy dandy scissors and I stitch them together. And so where that happens, I get a point of inflection, a poi. And we talked about this in class the other day. And I summarized it by saying that points of inflection are where concavity is changing. So I'm changing from concave down to concave up, or vice versa. So remember, the critical numbers for my function are where I have found the zeros of my derivative, or where f prime is undefined. So I'm either setting it equal to 0 and I'm finding the zeros, or I'm figuring out where it's undefined. And so when my function is increasing, I know that the slope is positive, and when my function is decreasing, I know that the slope is negative. So therefore, my function will be concave up when f prime is increasing, and my function will be concave down when f prime, you guessed it, is decreasing. Whoops. And if you go back and look at the picture up above, so the top left picture where it was concave down, if I look at that, I know that my function was changing from a positive slope to a negative slope, which is what made it concave down, and therefore, easy to tell, it has a maximum. That was that upside down parabola. And in the second picture, when I went from a positive, actually this should be backwards. This should be a negative to a positive. Then I had the concave up graph, and I can see that that has a minimum. Make sure you make this change, negative to positive.